Thank you very much. Well, welcome everybody. Thank you very much for your time in attending this seminar. My name is Jason Hanna. I'm the field sales engineer for IMO Automation and IMO Precision Controls. And today we're going to outline three types of enclosed solar disconnects that we are illustrating through the altE store. Our agenda today is going to consist of a few things, and it's not a very long presentation because essentially we have a set of disconnects for specific purposes. So it's just talking about two applications essentially. However, we wanted to give you the whole product breadth of it, as it will, so that you can properly size your disconnects and so on to your applications. So the first part of the presentation will be the introduction to IMO Automation, a little bit about us. A little brief history of IMO as well, too. I'll be then going into the product overview, illustrating features, something called the switching difference, which we'll get into the difference between AC and DC disconnects, as well as the installation benefits as well to the disconnects as well, too. I'll touch on a couple of competitor comparisons. Normally customers will use these other manufacturers for traditional disconnection. However, we have a suitable alternative, and we'll show those two comparisons. We'll then get into the two applications I was mentioning about for the SI32 disconnects, followed by the conclusion where we'll illustrate the products, contact information, and then open up for questions as well, too. My colleague Joe Covington is joining with us on the panel, and he can answer any questions on the chat. Otherwise, if I can take questions at the end of the presentation, that would be fantastic. Okay, so a little bit about us. IMO Automation is a division of IMO Precision Controls, and we were established in 2016 to support the US and Canadian markets. IMO Precision Controls is a British-based manufacturer of high-quality electrical control panel, automation, and of course our safety switching products for the renewable energy industry, and we've served these markets collectively for over 50 years. Our company is basically a collection of sales professionals, engineers, logistics professionals. All of us are dedicated to a high level of customer service. Just briefly, a little bit of history of where we came from in the early days. We were founded by a gentleman in the UK named Sir Morris Hatter. He founded a company called Key Switch Relay, which a lot of the relays are still in existence today, mainly in the control panel, electronics, film industry, and so on. He managed to get into that industry and do very, very well with it, which launched IMO into an industrial controls division for more power relays and contactors and so on. It got us into more PCB terminal block opportunities, which led us into the mid-'80s, which really brought on a new set of fresh products for us, one of them which is our Jaguar AC motor drives. These drives are still in existence today. We still manufacture the high-quality performance drives today in the same way we did back in the '80s. Moving forward into the mid-'90s, we're still leading-edge technology for our industrial controls and micro components and so on. But it was in the mid to late 2000s where we discovered that there was an opportunity for products in the solar and, of course, PV renewable energy business. A lot of customers were coming back to us asking for switching solutions. We came up and designed and engineered the first true switching DC isolator with full UL 508 approval. And we'll get into more of that, more of the technical detail in this presentation as well. Coming out of that, we also developed a first off-the-shelf solar tracker, which is our solar cube. No programming required, just entering your time and date and GPS coordinates, and it controls a single or two-axis controller. And then, of course, which is our really big success in North America, is our Fire Raptor, which is our module-level rapid shutdown system without the use of power line communications. So let's get into the SI32. I'm going to go through the product overview and cite the features as well. So first, you'll find all this information, of course, on the altE website. I want to take you through some of the part numbers in greater detail and give you full descriptions and how these disconnects are ordered. We start with our SI32 PEL64R-4. This is our traditional NEMA 4X IP65 enclosure. It's called the elongated enclosure, so it has a little bit more room for wiring. It's a 4-pole disconnect, switching 2 strings. The maximum voltage for this disconnect is 600 volts DC for the 32 amp rating. Dimension-wise, it's only 180 millimeters tall by 98 wide and 107 millimeters deep. We then go into the larger disconnects, which is our 6-pole, our SI32 PEL64R-6. Which is a same enclosure rating, NEMA 4X IP65. In this case, it's a 6-pole, switching 3 strings. Again, same as the 4-pole, it's going to be a 600 volt DC disconnect, then 32 amps. And the 8-pole, which is right beside it, shares the same dimensional enclosure ratings and so on. The only difference is it's an 8-pole switching 4 strings. And I wanted to sort of focus on this as well, too. We've had a lot of questions about wiring of our disconnects, and I want to take a moment to sort of expand on this. You'll see on the first disconnect here, we have our 4-pole disconnect, switching 2 strings. All of our disconnects are rated 432 amps as long as you switch the positive and negative. So in this case, we have a 4-pole disconnect that can switch 4 poles, but essentially what you're doing is you're switching 2 sets of strings. The positive and negative has to break in series, and that's how we can obtain the 32 amp rating. You'll notice that the 6-pole, you'll see that we can switch 3 strings, again, with a positive and negative in series, and then the 8-pole, which has the 4 strings, positive, negative in series. One thing to note is when you look at the data sheet or the little data sheet that comes with the disconnects, you'll see the wiring diagram, and you'll notice that the pins coming in, the positive and negative coming into the disconnect, are going to be named, let's say, 1 and 2, and then the output will be 3 and 4. But when you look on the disconnect, you'll see that the poles 1 and 2 will be on the top left side of the disconnect, and the pins 3 and 4 on the bottom right side of the disconnect. In the next few slides, you'll see the reason why. The wiring of this is done in such a way that the rotary disconnect inside actually switches on a diagonal. So just follow the wiring diagram of the schematic that comes with the disconnect. So main features of the disconnect, it's a market-leading design. We have been noted to be smaller in size, and this is due to the switching method we do for engaging and disengaging the DC current. We have the very first patented safe lock-off feature, and I'll get into that and why that's very important when switching off and isolating PV circuits. The maximum rating of this disconnect is 32 amps at 600 volts DC, and this is in CUL and UL for North American, Canadian, and US approvals. And guaranteed arc suppression, and generally that's between 3 and 5 milliseconds. And this is due to the switching mechanism that we use. It's an operator-independent switching mechanism. This comes into play, especially when you're switching the disconnect on and off. You want to ensure that that switching action is done as fast as possible. In this case, we've designed a mechanism in it, which will probably be in the next slide, that actually takes that speed away from the operator, so that the switching is consistent and we're guaranteed that arc suppression. We use knife edge contacts, and our plastic enclosures are duly rated at IP66 and NEMA 4X. And again, as I mentioned before, we are UL and CUL approved, but however, CUL approval goes to UL 508. UL approval for the States is UL 508I, which is an isolation status. And we do that by virtue of the safe lock function. These are only available in a non-fused version, and we are approved to be used in a UL 9540A switching installation for energy storage systems under NEC 706.15. And of course, which we'll illustrate, we're more than covered for the NEC 690 switching as well. Okay, something that it had been asked a lot about is the installation, some of the added installation features of our disconnects. And it's not really noted in our products manual, but I think it should be brought to light here. We do have CUL and UL approval for multi-conductor, so you'll see that we can get up to 2 conductors per terminal block. Some people want to do a pre-combine coming into the input side of the disconnect. The circuits are very well marked. As I mentioned before, if you were looking at the disconnect, if this was a top view, the same set of terminals you see here are actually mimicked on the top. In this case, 1 and 2 terminals are up here, but 3 and 4 are over down here. And I mentioned that crosswise terminal installation, and that's due to the rotary style that the disconnect goes. In the enclosures, there's a large, as you can see here, a large capacity, a large space. Should you want to do some custom wiring and so on, you're not putting overdue stress on the wiring. It's better for wire ratio or wire radiuses. Some other key things too, we have captive screws, so the screws won't fall out during installation. We also have, if you notice down here, we have embossed holes on the top and bottom of the disconnects. And this helps out, especially if you're using a stepper bit. You can use these as guides to drill out your holes for the strain reliefs and so on. Very helpful function. You can bore them out farther or larger if you're using larger size of maybe a 1 1/4 or 1 inch type. You can drill it a little bit larger. The one nice thing about the installation I like is the integrated mounting hooks. So on the bottom of the disconnect, you'll see that there's these hooks. And what you do is when you're mounting these, you would install the screws onto whatever, if it's a pole or the extrusion or what have you, and you just hook it on. Leave it a little bit loose so you're able to move it a bit. And then when you installed it and it's level and so on, you then come to the top of the disconnect where there's a caption hole here, and you're able to put the top screw in and secure it. And now you can mount the top and bottom and secure it to the extrusion. So it's little features like that. It helps in the installation. It's a little faster, a little easier. It's better for the installer. So the switching difference, we've seen, and the reason why we came out with the DC disconnect is we've seen over history a lot of AC disconnects from manufacturers that have progressive problems with AC disconnection, and it's been progressively improving. However, the main issue is still the speed of switching. It's still controlled by the operator in traditional AC disconnects. A slow switching of the contacts will lead to an increase in time and arcing that occurs across the contacts, and over time that arcing will deteriorate the contact and could present a hazard of fire or failure. So AC disconnects used for DC will tend to be oversized to compensate for the arcing, along with generally they'll have large jumper wires and so on across the poles. Here's a sort of an illustration. You'll see that the traditional AC disconnect, that's contact on contact. You'll see that the operator can influence the speed of the disconnection and connection by just moving the contactor or the handle slowly. This is our rotary style disconnect. And you'll see that it actually goes super fast. The video you can't really see it, but it's roughly about 3 to 5 milliseconds of switch time. And that's in the on and off position. And the reason is the disconnect was specifically engineered for DC current switching. Now it does retain an AC approval as well too, but its primary is for DC current. We do have a series of AC disconnects that take care of AC, but we wanted to make sure that this was an efficient means of switching DC current. It composes of a high tension torsion spring, which is on the right-hand side, with a built-in plastic piece, which is a trigger, and it's like a trigger clutch. So what happens is when the operator starts twisting in one direction, it puts tension on that spring, and when that trigger, that release rib, it's kind of like a little kind of a piece of plastic that's risen on it, it will actually trigger the spring and move the clutch. And what that will do is it will in turn move the internal switching on its own, and that spring is incredibly wound. So when you're moving it, you'll feel the resistance, but as soon as it fires, you'll hear it. It's a banging sound, and you'll know that switch has been effectively turned on or turned off with very, very little sparking. And the reason is, and here's a good illustration of the switching mechanism. You'll see that the switch plate rotates, and hence the reason I mentioned before that if you're looking at a disconnect terminals, you'll see that pins 1 and 2 are on the upper left-hand side, pins 3 or 4 are on the right-hand side, and that's because it's switching on the diagonal. So you can see that the actual switching mechanism is very different than conventional means. We also combine it with arc extinguishing plates. You'll see that these will switch contact on contact. However, when the switch engages and disengages, the actual arcing occurs on the side of the contacts, which is very, very little surface area. So if there's a little surface area, there's less chances of arcing. We also have arc extinguishing ribs, and this just basically quashes any remaining oxygen to the arc itself, so it further reduces the arcing process in the chamber. Because we can control this arcing process, we can control the temperature within the chamber, hence the reason why our disconnects operate cooler and they can be manufactured smaller. And we're talking about the market-leading design on it. We have this because of the fact that we are able to control that arc flame. We don't oversize to accommodate amperage. Whatever the amperage rating is on the label, it's what each string will switch. Now, I was mentioning about the safe lock. This is very unique to IMO, and this is something that UL brought out under the 508I category, that we needed something to ensure that there wasn't a false representation that the disconnect was switched should a contact be welded. So this is a switching option or a feature that we actually developed on our own, introduced to the market, and it's such that the handle itself is mechanically linked to the switch operator. So the theory is should a contact weld, in the likelihood that it welds, and we've yet to find one, the disconnect will not be allowed to go into the off position. Now, the safe lock was added because in the chance that, let's say the spring, the contact was allowed to weld, but let's say it was in a position where the spring could allow it to go forward and you're able to get that to the off position, it would be very, very hard to. The safe lock is a secondary position, and it's the only position that has the lock off provision. And the reason we do that is the safe lock position is mechanically linked to the spring mechanism. So if the contact or if the contacts in the rotary chamber do weld, it's physically impossible. You cannot move it to the off position without breaking the handle itself. And they do this because, like I said, if there was a fault, they don't want to have the ability of locking off a disconnect and give a false sense that the current's been disconnected. You want it to remain on so that the operator can identify that there is a possible issue and disconnect from other means. Our disconnects, we can actually document over 6 million installations worldwide with no reported failures. We've engineered these to be highly reliable and definitely longevity as well too. We still have disconnects in the field when we first introduced these in 2009, 2010. In our manufacturing process, we only manufacture with high quality materials and of course workmanship as well too. A lot of this can be also included in our solar products catalog available through the altE store or on our website. So let's look at some of the competitor comparisons. And again, we're just comparing feature for feature. We believe that everybody has a place, and our competitors also have a place in the market as well too. We just want to put some side-by-side comparisons as well. So we're going to start with the Square D HU36 1RB. This is a traditional 3-pole disconnect. It is a metal NEMA 3R enclosure. Dimensions are 378 by 168 by 124. That's kind of this footprint of a lot of AC disconnects out there as well too. That's that size and that dimension. Its rating is 30 amp at 600 volts DC, and the altE price on the website is $165 US. In comparison to an equivalency, we have the SI32 PEL64R-4. It is a 4-pole disconnect. In this case, we have a plastic NEMA 4X or IP66 enclosure. Our dimensions are considerably smaller at 180 by 98 by 107 millimeters. And we boast a 32 amp at 600 volts DC. And of course, you can see with a price difference, we're only at $72.81. The wiring is also a big difference as well. Because it's using the traditional 3-pole disconnect arrangement, they are also switching the positive and negative as well too. They also introduce switching positive and pause as well. As long as it's in a series circuit, you have to switch 2 poles. So we have a 3-pole disconnect. However, they can only switch 1 set of strings, and that's the wiring diagram according to their data sheet as well too. You'll see looking over at ours, we have the 4-pole disconnect, and in this case, we can switch the positive and negative, but because the switching mechanism does an effective job of getting rid of that arcing, we can actually, we don't have to run it through multiple poles, just 2 poles, and we can also make it as a 4-pole switching 2 circuits. A popular disconnect we've seen before is, of course, the Eaton DH161 URKN. It's a non-fusible type. Like the Square D, it's a 3-pole design, metal NEMA 3R enclosure. Dimensions pretty much almost the same size as the Square D. Same electrical ratings at 30 amp at 600 volts DC. However, price point being at $395 US according to the altE website. In comparison, again, we're going to use that SI32 PEL64R-4. Again, it's the 4-pole. It's a plastic NEMA 4X IP66 enclosure. But again, the dimensions are quite a bit smaller. The electrical rating is 32 amps at 600 volts DC. Another thing to add too is we do have that safe lock provision as well, which I don't believe the Square D does. I know the Eaton does not. It's just a straight on and off. And then lastly, like I say, that price difference as well too. The Eaton also has to switch, in this case, it switches all 3 poles in series. It actually has jumpers already facilitated within the disconnect. But again, it's a 3-pole disconnect, only being able to switch 1 string, where again, ours is a 4-pole switching 2 strings. A little bit more effective, a little bit more bang for the buck, enclosure size, as well as the number of strings you can also switch. And then the other disconnects that we offer on the altE store too, which is added convenience, especially for ground-mounted arrays, is we have our SI32 PEL64R-6 and SI32 PEL64R-8. These are a 6-pole and 8-pole respectively, switching 3 and 4 strings. Unfortunately, the Eaton and Square D do not have something in this fashion that can be compared to it. So you're able to do a little bit more with our disconnects when it comes to switching the number of strings. A couple examples of where you can find our disconnects. This is more of a traditional one that we've seen a lot before. This covers the NEC 690 ruling, and it's also meant for convenience as well too. Essentially, a readily available disconnect must be put in proximity of the arrays. In this case, we have 2 panel arrays here just as illustrations, so 2 strings. So we've used a dual string disconnect. That could be our 32 amp dash 4, the 4-pole 2-string disconnect. So we've got 2 strings coming in there, both switching. And should the underground wire need to be isolated or the inverter need to be isolated, you can do that quick and easy at the site as well too. Because these disconnects are rated at NEMA 4X and IP66, you're able to install these under the solar panels outdoors, and it'll resist all the harsh rains and snow and so on. This is very effective, especially like I mentioned before, if you have multiple strings. So you take advantage of the 2, 3, and 4-string disconnect options. So you don't have to, you can have these before the combiner or after the combiner, I guess. It's nice because, as I mentioned before, it isolates the ground array from the underground conductors in case of servicing that needs to be required. So it's a means of convenience for maintenance and service. where you're going to find, and you're going to see our disconnects really starting to come into play, is when it comes to energy storage and battery systems. Under NEC 70615, you must have some type of DC disconnect within line of sight or 5 feet of the connected equipment. So in this illustration, this is a battery storage, maybe a battery wall or what have you inside the garage. As long as there is a disconnect, a DC disconnect of some sort within that 5 feet constraint, that's totally within code. Because it's battery storage, the limitation of the voltage is 600 volts DC, which is perfect for these disconnects. And a lot of them don't go past the 32 amp mark as well, too. There's a little caveat as well in the code. Should you be putting the DC connection, DC wires through walls or buried underground and so on, they in some cases, it's recommended to have a second disconnect before the inverter as well, too. And that's mainly for servicing and, of course, disconnecting the conductors from the disconnect to the inverter as well, too. So in this case, you can see that it's just a closed loop system here. AC power is back to the charge control at the other end of the garage. But when you disconnect the DC power going to the inverter will tend to shut down as well, too. Like I mentioned before, for any information regarding our products, definitely visit the alt store under the store category. We're under the electrical enclosures and safety, under the load enclosures. All ordering codes, information on the disconnects, technical data, technical ratings, and everything you saw in this presentation is found on there as well, too. Any questions the team at alt store can answer as well, too. That pretty much wraps up the presentation on the disconnects. I'd like to open the floor up if anybody has any questions.
So Jason, we've got 2 questions here. We've got one for Taylor and one from Stefan. We'll start with the one from Taylor. So Taylor asks, when designing equipment for string voltage, we need to design for max anticipated string VOC, correct? For instance, if we're designing a string with STC parameters of 14.67 amps and max VOC at 880, we need to select a disconnect rated for 1,000 volts.
Okay. Yeah, generally we've always used the VOC. At least that's what our UL standards require. To say whenever you're designing a disconnect, they recommend the VOC. As standard testing conditions is more realistic, but for UL purposes, they wanted us to utilize the VOC or the short circuit.
Okay. Taylor, does that answer your question?
Mm-hmm.
Yes. Okay. And then we have one from Stefan and another one that just trickled in. What is the largest wire size that your switch can accommodate comfortably, both THWN and PV wire?
I have a revised sheet of that. I know commonly right now, a lot of people are using 10 gauge. And the only reason I say that is that's been the most questions right now is how many 10 gauge conductors can we put in the terminals? I do have a revised thing from our team, which illustrates the wiring. I can facilitate that if somebody wanted to give me an email address or something like that. We'd be more than happy to share that with you.
Stefan, we'd certainly be willing to share the slides. Do you mind putting your email address down? And we'll come back with all the UL documentation too. So as Jason was answering that, if you go through our brochure, our solar brochure here, you'll see the specific wire ranges.
Correct.
And I believe it's either 6 gauge or 8 gauge all the way up.
So. Yeah, on the bottom of, I think it's page 13 on the solar products catalog. The only thing it doesn't show is the number of conductors, but yeah, that is exactly what I was gonna to email is that portion of page 13, or no, sorry, page 20 of the catalog.
Perfect. And then we got one that came in from Daryl. We've got a couple others trickling in too, guys. I'll get to Adam and Taylor. Will come back to you as well. Does your disconnect have a remote control to turn off battery but not running the 48 volt outside?
Yeah, no, we do not have a remote control option for these disconnects.
Okay. And then coming back to Adam over here, regarding the multiple conductors CUL rating, does this include being a combiner for solar strings?
Well, that's the thing is we don't have a UL document that says that we are approved as a combiner, but it's common practice in a lot of cases that we've seen is they'll put two wires into one terminal. It'll combine in the input of the terminal, but it's not rated as a combiner. It's more of a convenience.
And then Taylor says we're using 8 gauge. I think
Oh,
everyone saw
okay.
that. I think Taylor was referencing to another project. And then on the spec sheet, why is the UL not approved on some disconnects at 1,000 volts and IEC does? Taylor, that's a great question.
Mhm.
I'm going to chime in here, and I'll let Jason chime in as well. We run up against it all the time, and as you kind of thumb through there, you will see some of the more of the IEC standards. We actually have 1,500 volt rated disconnects under IEC. UL requires a certain distance between the contactors for 1,000 volt and higher approvals. So that's why you see it on, let's say, the 40 amp range and higher, and not the lower 32 amp or 25 or 16. So that's
Yes.
where that is. Yeah.
Essentially, as Joe said, you have a clearance between, like this clearance is adequate for 600 volts DC. However, for 1,000 volts, I don't know if you can see it very well. You can see the distance is a lot bigger. So yeah, as Joe said, it's just a UL clearance detail that differentiates between the lower amperage disconnects and the higher amperage disconnects, just the size of. But now in saying that, you can use higher amperage disconnects for lower amperage 1,000 volt applications.
Yeah. Yeah, Taylor, just a little UL nuance. That's all. So, and then Daryl comes back and asks another question here and says, how about fusing?
I believe on the document on our products catalog, I believe there was a section on fusing. I'd have to double check again. It's been a while since I've been on that, but well, first of all, we don't have a fuse disconnect option, unfortunately. But we do have an interrupting capacity rating on it, and then you just fuse coordinate with that. So we can also get that as well too.
And Daryl, if you'd like, you can put your email down too, and Jason can follow up and send you some more documentation if you're specifically looking for fuse sizes.
Yep.
And then Gail sent in a follow-up question to Daryl's comment and says, but Daryl, it could be, a quote unquote break in the circuit to a contactor relay with greater amperage disconnect.
Interesting. Yeah,
Gail, would you mind elaborating on that a little bit more?
The other thing is, and thank you very much, Jason, great presentation.
Oh, thank you.
And just so everybody knows, Jason and Joe will be at the 3 o'clock open networking. So you guys can come and, ask any questions and have a nice conversation there as well.
Mm-hmm.
Absolutely. And Gail, thanks for that elaboration. So he mentioned the battery bank needs higher amperage capacity. So you're absolutely correct, right? If you're looking for a true battery disconnect, you could be anywhere from 150 amps all the way up to 500 or 600 amps, just depending on the application there. So you are absolutely correct. Yes.
Yeah, we do not have higher ampacities that can handle the 400 amp and so on. And I believe too, there's also a UL specification for a UL 98 or a hard stop type disconnect. So that we do not have, but for energy storage systems and smaller battery systems and so on that can accommodate the amperage and voltage, we do very well. Offline systems as well too.
Does anyone else have any other questions or anything?
All right, excellent.